Hi everybody. Okay. I will start in 1 minute. So I see that 30 viewers are watching our webinar. So I would like to start uh, with an important point for me. You know, yeah, probably you heard it. Uh, an earthquake, a disaster earthquake happened in Turkey. It's a huge tragedy. People people are waiting to be rescued, uh, and the rescued people are freezing outside. They're waiting for tents. They're waiting for food. Uh, yeah, unfortunately, it's a great tragedy. So 10 Turkish cities are affected from this. So please donate for earthquake. Please, we need your help. People need your help. So I see this as a chance uh, to say this. Actually, I didn't want to start this webinar, but I saw this as an opportunity. People need your support. People need your donation. Doesn't matter how much, $5, €10, doesn't matter. Really doesn't matter, but it matters for the people there. People are dying. People are freezing. People need support. Yeah. And I repeat it again, please donate for earthquake disaster in Turkey. Ahbap Derneği. Ahbap is the biggest organization, civil organization in Turkey, and also Izmir municipality uh, accepts donations. So please donate for earthquake disaster. If you do it, please inform me via email so that I know if this call worked for the people who are watching this webinar. Thank you in advance. Yeah. So let's start. Let's start our webinar. First of all, I would like to introduce myself. My name is Can Acar. I'm the founder and engineering manager of Mechatnom. I would like to introduce myself. I've been working, I worked a lot as an Autosar software specialist for 12 years um, at major automotive giants such as BMW, Robert Bosch, Audi in Germany. And I have been working as a CTO at Mechatnom since 2019, December 2019. I'm a licensed ASPICE and functional safety expert. And yeah, I would like to introduce you also Mechatnom. Mechatnom is a technology company that develops for the first time in Turkey automotive software modules, Autosar software modules, and exports automotive software to automobile manufacturers and suppliers abroad, especially in Germany. And we have a goal to develop more software modules and manufacture automotive systems and produce real solutions, real automotive solutions in Turkey to the world. So with a total of more than uh, 15 years of experience from the past. We are an automotive technology company that develops Autosar software modules for the first time in Turkey, as well as designing automotive electronics products like platform electronic control unit and the steer-by-wire steering system. So we have developed many Autosar software modules and sold them both domestically and abroad. Among our customers, such as ISMAC, Karel, and Metaxan, which develop products for BMW, TOGG. We are our modules are integrated into different systems from different OEMs. So our areas of expertise include developing, integrating, and testing embedded software and automotive electronics that are fully compliant with automotive regulation, steering systems, diagnostics, providing technical support to our customers, in particular in the areas of functional safety and ASPICE. So, our company is certified by ISO 9001 and ASPICE capability level 2. So we are a candidate of IATF 16949 and ISEX level 3, but also cybersecurity management system. So we won different prizes in Turkey, Best Automotive Initiative Award, winner of OIB, Feature of Automotive Design Competition, and so on. We are the first and only Turkish development partner in Autosar, but also Komasso. We are a member of biggest automotive community in Turkey, TAISAT, and we are a member of Automotive Exporters Association Turkey. So we developed all Autosar software modules with cybersecurity, new cybersecurity software modules too. Our software modules are integrated into different systems, and we developed our own Autosar configuration tool. We developed and manufactured the first SLD electronic control unit in Turkey, which includes already cybersecurity software modules, Autosar software modules like DCM, DEM, network management, and bootloader, and so on. On the other hand, this platform control unit can be used as an off-the-shelf product, but also it can be customized for different purposes like a body control unit or telematic control unit. So those were the completed projects, and we have also ongoing projects like steer-by-wire. So at the moment we are developing steer-by-wire steering system, which offers an enhanced safe steering, and also an enhanced excellent steering experience. So today I will talk about Autosar. What is Autosar? I will talk about layered Autosar architecture, and I will introduce each layer of this architecture. So for the ones who works with Autosar, it's nothing special, but basics of Autosar. But I think for some Autosar experts, there are really vital information in Autosar and functional safety part. You can stay and watch the presentation and our webinar. Doesn't matter if you are newbie or if you're experienced. I'm looking for your feedbacks after this webinar. Thank you for watching and listening. So let's start from Big Bang of automotive. Our vehicles, we are driving our vehicles with approximately 100 ECUs, electronic control units. So electronic control units are driving the cars, and software modules are driving the ECUs. So our software modules are controlling the ECUs. That's why software modules, automotive software modules are vital. Yeah. But before that, before starting that, I want to give short information about Autosar. Autosar is a consortium. You can find this information in Wikipedia, actually, but I want to mention it in short. It's established in 2003 by OEMs, giant OEMs like BMW, Daimler, Volkswagen, Ford, GM, Toyota, Stellantis, Continental, and Bosch. So, as you know, designing an electronic system for a car is very comprehensive, complex, high risk, and highly costly task. So, with an increasing number of complex functions every year, the number of electronic functions is increasing, which means the risk is also increasing. So, the idea of Autosar came from vehicle manufacturers and suppliers to prevent the continuous redevelopment of the same or similar software components. Autosar is a methodology for system and software architecture developed by automotive manufacturers. It's an architecture, first of all, and methodology. Worldwide development partnership for the automotive industry. It provides this partnership between partners. So at the moment there are different partnerships with different various tasks, various responsibilities. So premium partner plus, premium partner, associate partner, development partner, attendee. So as a developer partner, we are responsible of developing new standards, new technologies, and reviewing them, but also testing them. And we are the first and only Turkish member of Autosar. Yeah. So let's begin. Let's start with the motto. The motto of Autosar is cooperation on standards, competition in implementation. So in 2003, OEMs realized that they don't have anything with basic software, basic functionalities, because the competition comes from the application. So in the end, in the end of the day, consumers buy the cars, not the developers. I mean, the consumers don't interest in how the basic software works, but they're interested in how good applications or how different applications are, how attractive they are, and how accurate they are implemented. That's why motto explains itself already. Cooperation on standards. Let's cooperate on standards. And we cooperate here, and then we can compete later in the implementation. So Autosar describes a clear and standardized software architecture for vehicle development developed by automakers, auto suppliers, and component manufacturers. So Autosar concept offers a new approach from an ECU-centric approach to a function-based approach. The development of new control units is costly, as I said in the previous slide. So where's the effort there? Here. So basically there are two main types of code: functional software, and basic software. So functional software is the application software used primarily in a control unit. So this is where this is where the driver sees the functionality of any ECU, So uh, if we are talking about air conditions, so there are buttons. If you press a button, then something happens, and if you press another button, then another thing happens. So this is basically belonging to the application. So application software. And the basic software, standard basic software, is the software makes ECU function. So that means function software does nothing without any basic software. So first of all, your ECU needs a software. So how can we do it? We should flash. We should flash the ECU. So if you want to flash, then you need a basic software. If you want to flash, you need to be able to communicate with the ECU. So for communication, you need also another software module. And for diagnostics, for detection mechanisms, for entering error entries to your memory, you need another basic software. So basically, we can say 70% of the whole software stack belongs to basic software. So, and the biggest problem in automotive software is that the software is redeveloped for each new project. This increases development and maintenance costs. So the goal with Autosar is making the software hardware independent. That reduces development costs and risks, that improves quality and efficiency, that ensures transferability of software from one project to another. Reusability is ensured. The same software can be used for different products and OEMs. Standard software packages can be integrated into different ECUs. The vehicle network is scaled and optimized. So the scalability across different vehicle types and platforms is ensured. So application software or standard software can be configured for different types of vehicles. And it supports a wide range of functional areas: body, comfort, driving assistance systems, driving and transmission systems, chassis control, pedestrian safety. First of all, I should say that choosing the Autosar methodology for a company is a strategic decision. It's not one-time decision or one-shot decision. It should be a strategic decision. It affects directly how you do your job, how you develop your software with Autosar or without Autosar, or how many percentage Autosar. It doesn't force you to make your Autosar 100% conform. No, you can say this part can stay non-Autosar, and this part we will transform it to Autosar. So, but in the end of the day, it's a strategic decision. Yeah. And so in the layered architecture of Autosar, we divide whole software into 3 layers. So application software. Let me activate my laser pointer. So application software, the middleware, runtime environment, and the basic software. So the whole software stack is divided into 3 main layers, but also special drivers can be integrated into the Autosar environment. So in the end of the day, with this architecture, the software can be developed independent of hardware. There are different layers. So the three, I said there are three layers, and the third layer is divided into again three sub layers: basic, service layer, ECU abstraction and complex driver layer, and microcontroller abstraction layer. So let's examine each layer. So microcontroller abstraction layer contains hardware-specific drivers to directly access microprocessor-specific functions. If your ECU needs to communicate with CAN, then you need CAN driver, basically. And these drivers are provided by the processor suppliers, like NXP. If it doesn't matter which supplier it is, but um, uh, you can find Autosar conform drivers from NXP, for example. They provide you for free. Some of them for free, some of them for a fee. But in the end of the day, you should, as a developer, as a system developer or system supplier, you need to supply these drivers from the MCU supplier. So MCAL provides hardware-related registers, port and pin values required by the application layer between hardware drivers and RTE. So any driver is integrated into this layer here, about bus communication, about input output, about memory, watchdog, general purpose timer. Yeah, basically this is the only hardware dependent layer of Autosar. It is communicating. It's the only full layer which communicates with hardware directly. And the second layer is ECU abstraction layer. So basically, it is an interface. It's an interface between MCAL and the layers above. So it's ECAL, ECU abstraction layer, provides an interface to access all functions of the microcontroller. So it initializes the drivers. So every driver has an initialization function. Let's say CAN. So CAN has an initialization function, and this function is triggered by this layer. And most of drivers use a synchronous interface, and drivers that need a long time work asynchronously, for sure. On the other hand, there's another part, complex drivers, that enables us to adapt or to integrate any non-Autosar software module into our Autosar environment. Let's give an example. Your system includes a motor with its own motor driver, and this motor driver includes its own firmware. And then in your ECU, you need to reach this driver and control the motor. Which means you need to integrate the firmware into the Autosar environment, so that you can also integrate complex drivers into your environment, Autosar environment, with help of RTE, runtime environment. So it is also possible. So service layer provides standardized services required for application software and standard software. I worked a lot as an Autosar developer, and I basically developed diagnostic services, and I configured mostly Autosar modules in this layer. Honestly, yeah, I know very well how to how to configure DCM, how to configure DEM. So this is basically where we are configuring our system um, for having diagnostic services, for having DTCs, diagnostic trouble codes. Sorry, and um, to have chance to reach memory and so on, so that the upper layers become independent from the ECU and microcontroller. So in the heart of Autosar, RTE stays. RTE stands for Runtime Environment. So it's the heart of Autosar. You can imagine it as a call center. So the software modules are communicating with each other via RTE. So first of all, RTE executes the software modules. It makes them work. It makes them communicating each other. So it is the heart of Autosar. Everything, every single variable, every single function is defined there in RTE. So basically, when we configure something, when we define something specify something in the application layer, so that this layer is updated every time, and the code is updated in this layer every time, but also configuration files, um, depending on the Autosar software modules are generated, are updated. So I return back to RTE. So RTE is the interface between application and standard software. Autosar software components communicate with other components via RTE. So RTE makes Autosar software components independent of ECU. And development is specific to ECU, which means every time we will have a specific RTE for a specific ECU. It doesn't matter if you have the same software component here and here, but in the end of the day, you will have a specific RTE for ECU1 and ECU2, because every time we update this part, RTE. Yeah. On the other hand, Autosar provides libraries, which are collections of functions for specific purposes. Some examples, well, if I should give some examples to that, CRC. Okay. CRC library is essential for calculation, and also crypto crypto library is also essential for cybersecurity. So, and libraries are synchronous, and yeah. So let me mention about system design. So after having all drivers, you should have a configuration file, which is also specific to your ECU, to your system. So everything we are building on this configuration file. If we add a new software module, then the configuration file will be updated. If you configure something, if you add a new UDS services, if you change a parameter of CAN communication, then the configuration file will be updated. And with this configuration file, via using Autosar tools, you're able to generate the code and integrate into our ECU. So this was the part of basic software. And if I talk about application software, then we should think always visual function, visual function network. It's a communication mechanism that provides interaction between software components. In addition, application and infrastructure provides a sharp distinction between. So, um, virtual function network offers the following concepts. So it communicates with other components in the system. It communicates with sensors and actuators in the system. It provides access to standardized services such as reading and writing in Enviroment. It reacts to the mode change of the ECU. It communicates with calibration and management systems. So basically, what we do is we create some blocks as a software modules, as software modules, and we create the interaction, and we configure, we show them how they should intercommunicate, so that we have virtual function network. And for every time, for every specific particular ECU, we need to have a specific virtual function network. So it's not limited to communication between software components in the application layer, but also between standard software. So yeah, with VFP, Autosar objectives are achieved, which are modularity, interchangeability, repositionability, scalability, and reusability. So that what we do is we create some software modules in blocks, and we connect them each other, and we define ports in RTE, and we connect ports via RTE again. So that we can move one software component from a project to another project, from a system another system, from an ECU to another ECU. So VFP enables hardware-independent development of application software. RTE is the internal control implementation of this VFP concept. So we are implementing VFP with RTE, which means RTE. In the Autosar tool, we say how they should communicate each other. Okay, so the communication can be done cyclic or event-based. So this is a choice, and this choice is done in RTE. And RTE knows how you communicate or how your software modules are communicating each other. So RTE is executing this mechanism, this functionality. And it is the center of this functionality. It's the heart of Autosar. That's why it's the heart of Autosar. And as Mechatnom, we fully standardize these software modules according to Autosar, and we are enabling it to be used by configuring it for different ECUs. So there are different types of components at Autosar, and there are different components. Yeah, as I said, you can define, you can specify your module as a block here, and then you can create ports, and there are different ports like sender receiver and or a client server, or calibration parts, so that you can interact with other software modules. So so that it can be designed as a system of connected software components is very important. So in the end of the day, our system should be defined as a interconnected software components. So these are the tools we have in our hands. We have components, we have ports. So we paint them in an Autosar module, and there are two different component types: atomic component types. So basically, single software components are communicating each other. And the composition component is a component made of two software components. So we take this as a single component made of two software components interacts with a third software component. So, and I want to talk about also different, mainly there are two types of ports: provide ports and require ports. So provide means a software module provides something to the outside. Okay, it may be either a signal or a function. Okay, and require port means it requires something. It requires an important information from outside. It may be either a signal from outside or a function from outside. And the ports are then there are also subports like sender and receiver ports. So these are the inputs and outputs. So what are we sending out and what are we receiving from outside as signals, as data? And there are different port interfaces. There are three types of port interfaces in Autosar. So client and server ports. So services required or provided by software components. Sender receiver ports. Data is exchanged between sender and receivers via these interfaces, and there are calibration ports. So that static calibration data can be queried using calibration. Yeah. So I want to also mention that we use runnables for events and functions that can be triggered. The development of a software component may consist of one or more runnables. So the runnables are executed by RTE, and runnables use RTE functions and macros to get information from sensors or actuators or from other from other software modules. And runnables can be called cyclically or on an event basis. So this was the basics of Autosar, and I want to talk about Autosar and functional safety, which may be also very interesting to you. So Autosar provides different functional safety mechanisms like program flow monitoring, timing-related features, communication-related features, end-to-end communication protection, memory partitioning. Every requirement is linked to functional safety requirements. If you are interested in this topic, you can visit autosar.org and then visit the technical safety concept of Autosar. There are very good details there. So let's start with communication errors, which are basic in automotive. So as you know, as I said, there are more than 70 electric control units in a car. So these ECUs communicate and exchange data between each other. This exchange of data can affect functional safety. Systematic software errors caused by communication may not only be caused by the hardware of the ECU that sent the message. RTE in ECU can also originate from network communication modules such as COM and CAN. And all or part of the message received at the timeout may not be received. So there are different types of communication errors, like timeout, like CRC, corrupted message, or repeated message, or delayed message. So they're basically the typical communication errors caused by systematic software or hardware errors, like broken hardware, like systematic software errors. Yeah, and the best known mechanism is end-to-end protection. So Autosar defines 6 configurable end-to-end profiles, and Autosar which are also standardized to detect communication errors. And each profile uses a data protecting mechanism like CRC checksum from CRC library, counter, and a special ID, custom ID. So this is basically a header information contains CRC value and counter information. Yeah. So if the system has more than one ECU, then a special ID can also be provided. The end-to-end profile not only provides protection to the sent safety critical message, but also detects if there is a CRC message counter or timeout error in the received safety critical message. So how does it work? So let's say, let me introduce you the main function end-to-end PO2 product. So the product function is used to calculate the CRC of the message to be sent by the ECU and to set the counter value. First, the counter value of the message is increased by 1. So every single message is sent with a counter, and the counter starts with 0, and then it's increased by 1 every time. Yeah. And it is written to the first byte. And the data ID corresponding to this counter is read in the list delivered by the OEM. Using data and data ID, the CRC value is calculated and written to byte 0 of the message. And after the header part of the message is prepared, the message is ready to be transmitted with this header part. So you can see the structure of the transmitted or received data. Basically, this is the data we have. We need to send this or we need to receive this. And if this message is safety critical, then we need to see 1 byte CRC and 4 bits counter. So that we are able to detect if this data is corrupted or not, or if the counter shows us correct information. Let's say if we see 1, and the next time we should see 2. But if we see again 1, then it's a problem. It's a repetition. If we see 3, then it means it's jumping. The counter value is jumping from one value to another. And CRC detects. With CRC, we are able to detect if this data is corrupted or not. Yeah. So let's jump to the memory errors. In today's complex system software, modular software units often have different functional safety critical levels, like QM, SLA, SLB. And this creates the following problem. Software modules with lower SL level can access and interfere with memory areas of modules with higher SL level. And you can see in the example on the screen, a software module from QM or SLA level can interfere and override the RAM area written by the SLB level software module. This unauthorized write operation can lead to corrupt memory portions and overflow. This situation impairs the functional safety of the software. So, in order to ensure the functional safety of the embedded software, we developed a Mechatnom operating system, which creates partitions in the memory, and which prevents the interference of software modules with higher ASIL rating. In this example, we have partitioned our RAM memory according to the ASIL degree. We created an OS app. For each part, we have assigned a task to each OS app, and software modules are executed under this task. Thus, memory partitioning does not prevent access violations within the embedded system. So memory partitioning is implemented with our operating system using hardware-level MPU, memory protection unit, or memory management unit. So in short, memory protection unit as a memory protection unit prevents memory corruption by restricting unauthorized writing. This means the low-level software modules can only read but not write. So that we ensure the freedom of the interference. Yeah. There are also different concepts, like partitioning memory can be implemented in different concepts. You see one of them. OS apps are divided into two classes, trusted and non-trusted. So trusted OS apps, also called supervisor mode, and non-trusted OS apps, also called user mode. So in this example, we divide not only the RAM, but the software completely into safe and unsafe areas. Software modules belonging to the safe area can have privileged access everywhere without any restrictions, while the access of the modules belonging to the unsafe area to the memory and the OS is limited. Thus, any code, any software module runs in the non-trusted area cannot affect or change any data in the trusted area. And timing errors. Timing is an important feature of embedded systems. System behavior and reactions at the right time make the system safe. At this point, it's necessary to define the right time. A reaction is expected to occur within a certain time constraint. When configuring Autosar software components at the RTE layer, time constraints must also be defined correctly. If it is not defined correctly, the runtime of a software module is determined incorrectly, so that this module can block the other one. So mismatch between software modules. Apart from all this, budget overrun, time limit violation may occur. We expect a software module to complete its work in the time defined for it, not to dominate the OS resources. Any task load on the processor must be monitored and detected. Yeah. Besides that, deadlocks are always problematic for any safety critical system. Let's speak about Watchdog Manager. Watchdog Manager is a core software module of the Autosar architecture. It connects the timer to the corresponding software component. It monitors the runtime of the software component. If any error triggers the corresponding reaction instantly. And Watchdog Manager provides three surveillance mechanisms: live supervision, deadline supervision, and logical supervision. All types of surveillance use checkpoints. That's checkpoints, yeah. They are called checkpoints. By assigning a checkpoint, which has a reporting function to the monitored unit, the watchdog can control the operating frequency of this unit. By assigning multiple control points to the software component with live supervision, different points of the software can be reported. Monitoring and reporting are regular and cyclical. However, live surveillance alone is not enough. That's why time limit monitoring is used along with live monitoring, so deadline supervision. Deadline supervision, on the other hand, is not cyclic but event dependent. This monitoring looks at the transition time difference between two control points in a software component. The resulting value is expected to be higher than the minimum value allowed and lower than the maximum value. There's also logical monitoring, logical supervision, which allows us to check if the software is executed in the defined logical states. Yeah. So Autosar provides Watchdog Manager, which can inform the corresponding software module. Watchdog Manager may enter error code via Diagnostic Event Manager, which triggers error entry in Enviroment or RAM. The Watchdog Manager can also order the respective software module to shut down, and it can trigger the Watchdog hardware to restart the ECU. It can restart hardware and software immediately. So, as a summary, with Autosar modular, the software modules can be purchased from Autosar suppliers like us, Mechatnom, and can be configured and integrated into any system. Not only basic software modules, but also application software modules can be designed, and they are ready to transfer from one customer to another. It doesn't matter how many customers you have. You may develop your system for BMW, on the other hand, for Volkswagen, and you may want to use the same software in the application, so that you can transfer this software module from one customer, from one project to another. Yeah, for sure, if they are the same. I mean, if the functionality is the same, because every OEM provides its own customers, its own specific requirement sets, and it doesn't matter. You can still transfer, but you can also enhance your code. You can extend your code with new requirements from the new OEM. Yeah. And Autosar provides also mini-grade functional safety mechanisms, and yeah, they are very vital for any system. And Autosar also provides a new approach from hard coding to configuration. So configure, generate, and integrate the code. Thank you very much that you listened to me. I hope this webinar was helpful for you. Please write me your feedbacks. If the time was enough, if the topics were interesting to you, and if you have any questions, please don't hesitate and write us via email. I'm very open to any specific questions to discuss. don't hesitate, please. And yeah, I'm ending my presentation here, and I want to remind you to make some donations. Make donations for earthquake disaster in Turkey. People are waiting for your donations, and we are always donating to Ahbap, either to Ahbap Derneği, Ahbap, or Izmir municipality. Thank you so much. I wish you a great day. Bye-bye.